Recall that attributes are variables that are discrete or categorical. For example, the output measurement is good or bad, or perhaps yes or no, or acceptable or unacceptable. We may also count the defectives. For attribute data, we are primarily interested in two charts. First is the P chart, which looks at the percentage or proportion, that's where the P comes from, of defective units. And the second is the C chart, which counts, that's where the C comes from, the number of defects. Let's first discuss the P chart. The underlying population will be a binomial distribution. Recall that a binomial distribution only has two possible outcomes. In our case, this would probably be good versus bad. Even with a population distribution that takes the form of a binomial distribution, we can still apply the central limit theorem to assume a normal distribution for the sample statistics. To calculate the limits for a p-chart, we first calculate p-bar, that's the mean fraction of defects in the samples. Again, we'll need a z-value. We will often use 3. And then we need to calculate the standard deviation of the sampling distribution, which we call sigma sub p hat. Notice that its formula requires p bar in n, which is the number of observation in each sample. So let's look at an example for a p-chart. Suppose we work for an insurance company and that our insurance claim data entry specialists enter hundreds of claims into our database every day. We are interested in determining if our data entry process is in control or not. So we randomly select 20 data entry specialists to use. For each of these data entry specialists, we randomly select n equals 100 claim entries to test for errors. So we'll have 20 times 100, 2000 claim entries that we're looking at. If there is an error, we mark that entry as bad. Without showing the entire table of data, we can still see how we are doing. We see that specialist number 1 had 6 out of 100 errors, or a 6% error rate. Specialist number 2 was slightly better with only a 5% error rate. Over all 20 different data entry specialists, we have a p-bar of 4%. Then, using z equals 3 and calculating sigma sub p hat of about 0.02, it's slightly less than that, but I've rounded it here to make it fit nicely on the slide. We can compute an upper limit of 0.10 or 10% and a lower limit of 0 or 0%. Notice that the limits, once drawn, are not symmetrical. This is because for a p-chart we cannot have negative limits. So if you look closely at the lower control chart limit, we see 0.04 minus 0.06. That would give us a negative number, but we can't have negative limits in a p-chart. We see that specialist number 17 is above the upper limit with an 11% error rate. Therefore, the process is out of control. In this case, we know where the problem exists. It's person number 17. So what should we do? Obviously, we should fire that person. No, probably not. At least not immediately. Well, one option would be to have this person sit with the person number 3 or person number 19 to hopefully learn how they are doing their jobs with 0 errors. Both of them have no errors. Of course, you would also hope that person number 17's bad habits do not rub off on those two people that are doing good jobs. For a C chart, we are interested in counting the number of defects. The underlying population distribution will be a Poisson distribution, but again, applying the central limit theorem, we can assume that the sample statistics will follow a normal distribution. To calculate the control chart limits, we need to calculate C bar, the mean number of defective in the sample. We also need a z-value. Notice that for the standard deviation, we simply use the square root of C bar. This, as you may remember, is a special property of the Poisson distribution. So let's look at an example for a C chart. Red Top Cab Company keeps track of the complaints it receives every day about its drivers. Over a 9-day period, the following complaints were received: 3 on the first day, none on the second, 8 on the third day, etc. So first we need to calculate C bar. So we add up all of those complaints and divide by the number of days, 9. In this case, C bar turns out to be 6 complaints per day. Now we can calculate the limits and draw the chart. The upper control chart limit is about 13.35 complaints per day. The lower limit is negative, but we cannot have a negative value for the limits of a C chart. So we set it at 0. In this case, it looks like the process is in control. We may wish to investigate why we had no complaints on that second day to see if we were able to replicate that good outcome.